Hello students, this is Miss Shockley, and today we're going to be having a lesson over air masses and fronts. The first thing you need to know is that air always flows from areas of high pressure to areas of low pressure. High and low pressure systems produce air masses, and a high pressure system maintains the weather condition of an area. So if it's warm, it's going to stay warm. And low pressure systems result in changes in our weather, such as thunderstorms and rain. Here are some diagrams about high pressure and low pressure systems. You can see on the left, the high pressure wind blows clockwise around a high pressure, and then the air diverges, is moving away. You can see the arrows there moving away from it. If you look at the view from the side, you can see that the dry air sinks and goes down towards the land and then spreads out. At the bottom, the surface winds blow counterclockwise around a low pressure and converge, so the airs come in on a low pressure system. That's the view from above. On the view from the side, you can see how the air comes from the sides and goes back up as the moist air starts to rise. The next slide you see here shows a picture again of high and low pressure systems, and you can notice that the arrows represents the actual airflow. When we have a high pressure system, you need to know that that is good weather. We want to have a high pressure weather system over us for good weather. If we get a low, we know we're going to have storms or it's bad weather. Doesn't have to be bad, it can just not be as good as when it's sunny and nice outside. An air mass is a large body of air with uniform temperature and moisture content. Air masses can be classified as polar or tropical in regards to their temperature, and continental or maritime in regards to the moisture content or humidity. You can see abbreviations in this chart below. Each one of these words, the name of the air masses and what they mean, which will be important later on in some lessons that we'll be doing in class. The air masses that we have, low and high, move from west to east across the United States, and this is done so with the jet stream. In the visual provided, you can see where the jet stream is located during the summer and winter time across the United States. The map shown here is a demonstration or illustration of isobars, and they are lines that connect points of equal atmospheric pressure on a map. So this little area that I'm coloring in right here, all of this area within this circle is at one pressure. This area right outside between these lines, all of this is another pressure. So each set of lines outlines a different type of atmospheric pressure on a weather map. Fronts. Fronts are the result of two or more air masses colliding, and they can be classified as warm, cold, occluded, and stationary. Most weather changes occur along fronts. Weathermen make predictions about changes in weather based on the types of fronts interacting. Here at the top weather map you have here on the left, you can see there's an example of all four types of fronts. You can also see the abbreviations for the different types of air masses here that I'm also circling. So if we were to go back and look, you could see we have some maritime tropical, we have some continental polar, and then we also have each one of the different types of fronts labeled on this map. On the right, you have the symbols for each type of front. You have your warm front, your cold front again, stationary, and occluded. And lastly, here we have an example of a weather map. On this weather map, you can see the areas of high pressure, low pressure, marked in red on several different locations. You can see the isobars, the lines that go through that are examples of different types of pressure, and you can see the different types of fronts that are located. And that's a wrap.